mixtures and movements. So many real gases are mixtures. Dry air is a mixture, the air that we're breathing, percent by volume or particle number. It's 78% nitrogen, 21% oxygen, 1% argon, and about half, 0.05% carbon dioxide. Very small amount carbon dioxide, okay? So you can see here. Water vapor is trace to about 4%. Trace means undetectable to about 4% depending on where we live. So Florida has a much higher water vapor content than Colorado does. So Dalton's law of partial pressures says that the total pressure of a gas mixture equals the sum of the partial pressures that make up the mixture. Okay, so P total equals P1 plus P2 plus P3 plus P4, depending on how many we have. So for air, for example, we have the pressure of nitrogen plus the pressure of oxygen plus the pressure of water plus the pressure of carbon dioxide. Okay, so if we were to look at a problem here, a Dalton's law practice problem, a sample of hydrogen is collected over water, right? Gas, it has to be collected over water. Because we have to run it through water so that we can collect it. The total pressure is 760 millimeters of mercury. Millimeters of mercury is a unit pressure. If the vapor pressure of water is 20 millimeters of mercury, what is the pressure of dry hydrogen? Dry meaning not wet, okay? So P total equals pH2 plus pH2O, okay? So we know that our total pressure is 760. We're looking for our pressure of hydrogen, and we know that our pressure of water is 20 millimeters of mercury. So 760 minus 20 equals 740 millimeters of mercury. Okay, air is about 20% oxygen. So if the atmospheric pressure is 760, what is the partial pressure of oxygen? Okay, so here, if air is 20% oxygen, we just have to multiply 760 by in order to get the decimal, we would divide 20% by 100 to get 0.20. And when we multiply that 0.20 by 760, we get 152 millimeters of mercury. So as we talk about gases, diffusion is pretty important. Diffusion, and this will come up again in biology as well. Diffusion is the movement of particles from high concentration to low concentration until equilibrium is reached. Okay, we saw this last week when we did the little activity where I dropped, or you might have done it at home, the food coloring in the glass of water, either hot or cold. Okay, there's diffusion of particles. Those particles are moving from high concentration to low concentration until they're equally spaced out within the water. Particles are in constant motion and collide with other particles and surfaces. So the lower the molar mass, the higher the velocity, and the faster that they diffuse, okay? So the smaller the particle, the faster it moves. The greater the mass, the slower it moves. And kinetic energy is equal to 1/2 of mass times volume squared. So this occurs in liquids as well as gases. So like I said, that little example that we did last week. So which would diffuse faster, hydrogen or helium? Okay, so hydrogen, H2, has a molar mass of 2, and helium has a molar mass of 4. So again, hydrogen would diffuse faster because it has a lower molar mass, which means faster velocity. Which would diffuse faster, nitrogen or neon? Okay, so neon is about 20 grams per mole, and nitrogen, N2, is 28 grams per mole. So neon would diffuse faster because it has less mass, faster velocity, less mass, faster velocity, faster moving. Okay.